Today, we will quickly walk you through how to migrate your unstructured data on Cirrus Data Cloud in only a few minutes, all the way from deployment to moving the files to data integrity verification.
Hello, it is me, Maggie. You probably remember me from all those block migration demonstration. Yes, this demonstration is about our unstructured data migration capabilities, but our file and object migration is built on top of the same exact platform that powers block and hypervisor migration. Same CMC, same cloud platform. All the AI integrations and automations that you probably heard from me before applies here as well.
We previously created an introduction video that covers the entire Cirrus Data product family and talks about how unstructured data migration fits into the platform. Please feel free to check that out for a complete high-level picture on our technologies. I will put a link down below. Before we go through the actual file migration steps, it is important to know that Cirrus Data Cloud is our data mobility as a service platform. It is a single platform that manages all of your data migration needs at scale. Under this management plane, we have Cirrus Migrate On-Premises, or CMO, which is our SAN migration physical appliance that migrates data between fiber channel and iSCSI storage arrays. And then we have a software version of that, Cirrus Migrate Cloud, or CMC, which you can install on any Linux or Windows host to migrate any block storage. Physical, cloud-native, virtual disks, any block storage. Of course, this Cirrus Data Cloud control plane can be a cloud service, or we also have a private edition for air-gapped environments where you can self-host the entire stack, including the management plane. But either way, your data never leaves your data center. So these are our block migration capabilities. Now let's see how files and objects data mobility works under the same platform and same CMC software.
Remember, file migration shares the core platform as block migration. All these access controls, alerting, reporting, project management, APIs, agentic AI collaboration, deployment process, troubleshooting process, all these enterprise features automatically apply to unstructured data as well.
Cirrus Data Cloud works with any storage your host can reach. That includes local file systems, NFS on Linux hosts, and SMB shares on Windows hosts. Our storage integrations can assist you in connecting your hosts to your network shares, but you can also connect and mount the file systems yourself, and CMC will still work the same way since it is automatically protocol aware. Here's our setup. We have prepared a Linux host as a migration worker, which has a source data set of about 109,000 files at 15 gigabytes and an empty destination ready. Our host has access to both directories. Data will be migrated from the source to the destination.
Since this is just the same CMC software that our block migration users install on production servers, you are free to install this on any supported Windows or Linux host. It can be a client host, but most likely you will dedicate virtual machines for migration purposes. The CMC software is identical to what is used in block migration. Migrations driven by these hosts and your data, just like the block migration, are not cached on these hosts, and they are synchronized directly from the source to destination. So, no matter you are using cloud service or private edition, your data never leaves your internal network. The same logic applies when you install CMC on a different host, to migrate remotely with a different storage location, through a stable and secure connection between them.
So let's get started. The first thing we need is a project. So we'll come to Cirrus Data Cloud and create a new project. And today, we'll select Unstructured Data Migration alongside CMC. With this option enabled, you can see that a new Unstructured Data Migration option is now available on the side menu. Next, we need to install CMC on our host. I will copy the installation command and paste it in the shell. CMC will install and register to Cirrus Data Cloud all by itself. And this same command can be used on as many hosts as you want, so you are free to use any automation of your choice to deploy CMC at a massive scale. Let's head back to Cirrus Data Cloud, and our host now appears on the registered host list, which means the installation is complete. For scalability, you can deploy as many hosts as you want. While they are all registered to Cirrus Data Cloud, the migration is taking place directly on the host. This way, you can horizontally scale your migration as much as you need. Remember, a migration worker can be any Linux or Windows machine that can access your source and destination files. We are just like an application on a client host that consumes your files. Now, let's go and create the migration. From here, the wizard will walk us through a step-by-step configuration. We will select the source storage, destination storage, synchronization behavior, data filters so that we can migrate only the data that we need. We will then configure the automatic synchronization scheduling, QoS, and throttling schedule. If you would like to see how to manually create your migration on Cirrus Data Cloud, please visit our See It in Action demo video that walks through every single step in details. Remember, since our synchronization engine is always differential, only the changed portions of files count toward usage, just the blocks within the files that need to be migrated. Once we have configured our migration, we will go ahead and create it. The first synchronization pass has already started. A synchronization job has three major phases. The first phase is data discovery, which is to locate all the current data you have in your source and destination storage. The second phase is file or object scanning, which is to make decisions on what needs to be synchronized. Then third, of course, is the synchronization phase, where we will copy all the data and metadata attributes. And like we previously mentioned, all these are running together like a well-oiled machine. This fully asynchronous pipeline ensures that our migration workers are never waiting on each other and are always contributing to progress while staying lean on resource. During the file scanning phase, CMC also profiles and performs various analysis on your dataset. For example, here you can look at the type of data that you have, whether you have mostly VM files that are data reduction friendly, or you have mostly video files that likely require more raw storage. You may also want to know whether you have mostly big files or tons of small files. Age analysis is also an important one. You can see how old your data is and how often they get accessed. Knowing the distribution of hot, warm, and cold data can be very useful when it comes to storage planning and deciding your migration strategy. We are very actively enhancing the information that this process provides. Of course, just like everything else, all of these can be API driven. These analyses are running on every pass automatically. To run a scan-only pass, you can come to the action and select Discover Change Data. You can run this first or at any time when you want to know the data that requires synchronization. Now let me sync again to bring the destination up to date. We see that our 15 gig is synchronized just as expected, but also we have a 47% of data reduction. Remember how we talked about our engine is differential sync by nature? Using our deep expertise in block-level migration, our engine always only transfers the portions of file content that requires synchronization. With 3 gigabytes of changes on our source, there is only about 1.5 gig actually moved.
And whether you are triggering these passes manually like we just did, through MigrateOps automation, REST API, or your AI agent managing the migration through the MCP server, this licensing model stays the same, so you can trigger sync as often as you like.
Now the data is fully synchronized on the destination. We will next verify our data integrity. You can trigger a data verification to verify that the data we migrated matches the source. And it's done. We have all 109,000 files verified with 15.77 gigabytes of data and 0 errors.
Now, for those of you coming that are familiar with our CMO appliances for SAN migration, yes, this is the exact same verification process that you already know. It is powered by the same patented dynamic data integrity verification technology, except now it applies to files and objects verification too.
Now that verification is complete, we can generate a chain of custody report. This is the formal audit record of your migration. We have 240,000 audited operations included in this report. Since it actually contains the fingerprint of your data, this chain of custody report is stored directly on the destination storage, so it never leaves your environment. Each row of the report comes with the timestamps, action type, file information, and data checksum. You can trace through every action that has taken place. Once these are all completed, we can also come to validate our file migration. The file counts match. Directory structure also matches. The full tree from our source is replicated to our destination storage. Before we end this, you can also generate a migration report. It contains everything about the migration, including project overview, migration overview, source and destination details, full configuration, and complete pass history. This report sticks around even if the migration is later deleted. You can trigger more synchronization passes as often as you like. When you are ready to cut over, simply put your applications to read-only, do one final synchronization pass, and configure your clients to consume your data directly from the new storage. When you are done, you can complete the migration. And the migration is now marked as completed. Let's do a recap on what we did. We started simple by preparing a migration worker host that already has our source and destination pre-mounted. We installed CMC with a single command. Then we have created the migration. We ran the first sync pass and watched the engine build the file analytics while it moved data. After the first synchronization pass has completed, we triggered a new pass and saw our efficiency in action. We had a 47% subfile data reduction. After we're through with the synchronization, we triggered a verification pass and confirmed that data integrity of all 109,000 files. We generated a chain of custody for auditing, previewed it, and downloaded it. We eventually generated a full operational migration report and completed the migration. Aside from what we're showing you today, of course, security, scalability, performance, and verifiable accuracy are the core reasons why we added what you saw today to Cirrus Data Cloud.
Yup, just as they are in the block and virtualization migrations I showed you in the past. So, that is it from us. For more end-to-end migration demos and to stay up to date with everything we're building, head over to our YouTube channel to learn all about it. We will keep bringing you more migration demonstrations like this one, so stay tuned.